we also have Pan Jian, he's co-chairman, Contemporary Amperex Technology, CO, or CATL.
CATL, yeah.
CATL, thank you. Pan, let me come to you. Your thoughts, are we there yet in terms of beginning to declare mission accomplished, renewables are here to stay?
I think we're on the road, but very promising.
How far up the road?
The road is, the runway is very long. That means, great potential for the future growth. But at the same time, the technology is ready, despite the fact there is still a lot of challenges to overcome. But it's all engineering questions. And from CATL's perspective, we've been putting a lot of resources, and we are confident all these engineering challenges will be tackled along the way. Right? But before I started, I just like to point out, I like this stage. It's a circle. In Chinese culture, we love circles because circles means equality, means harmony, right? And that's probably very important in this, today's world, very turbulent and chaotic. But anyway.
So we will thank our organizers, the World Economic Forum, for bringing us
together. Absolutely.
In South Africa, we say make the circle bigger.
Yeah.
We're making the circle big.
And also going back to your very touching story about your hometown village, just like to point out, the solar basically at night, they can't light up the lamps, right? Because the solar dies down at night. It's the storage, it's the battery that powers the, the lights.
Yes.
Yeah, so energy storage is going to be, it has been and it will be a very critical component of the future power generation and power transmission, also power usage, because it has many features that make it a really critical and integral part, indispensable part of the future power. I think it's fast. It responds at the millisecond level to the grid. It's bidirectional. It has bidirectional dispatch capacity. And also, as Catherine mentioned, it's fast to deploy, right? Because most of it's pre-configured at the factory rather than being built on site. And it also has great flexibility, means because battery or energy storage, electrochemical storage can be deployed from power generation to power transmission to behind-the-meter applications. Meaning that at home you can install 10 kilowatt-hour storage, and on the grid, the largest one we are working on right now is 10 gigawatt-hour project, meaning it's 1 million times bigger than the home storage, and you can do anything in between. Right, so it's very flexible, from small to large to ultra large projects.
Yeah, you actually in part answered what I was going to be a follow-up question from myself, which is, to what extent would you say we are far up that road in terms of developing the technology around batteries and storage? Because one of the frustrations, as you can imagine, in villages is the capacity of those batteries.
Yeah, the capacity today is not an issue. And I think, as long if you put enough big size battery, there will be no issue. Then the cost. We've been able to putting a lot of R&D efforts to bring down the cost in the past 10 years. We've been able to bring down the average cost of a battery by 85%. Just in the past 10 years. And we're continuing working on new technology, like sodium-ion batteries, like condensed state batteries, and in the long run, solid-state batteries, to continue to improve the performance of the battery while pushing down the cost.
Absolutely.
And one thing about the cost is also at the grid level, especially to operators like NGER, also ACWA. We need to look at the cost looking at the cost from $1 per kilowatt hour to $1 per cycle or per cycle use. Because in the past couple of years, we've also been able to improve the life cycle of the battery.
Right.
Now we can produce battery up to 18,000 cycles.
Sure.
Which means, even it.
Put that in terms of years so people can connect and understand.
Put it in context, right? If it do full charge and discharge twice a day, it can be used for almost 30 years, 25 years plus.
Oh, wow. Okay.
Yeah. And also degradation is very important. You need to have slow degradation batteries, meaning that over the years, the capacity will not drop significantly, right? A lot of advanced technology at the material science level has to happen to make it a reality, right? But then at the grid level, as we increasingly embrace renewables as the power generation source, we cannot just look at solar or wind alone as the power generation source, as the percentage from all these intermittent power generation sources go up to, if they're below 15%, it's perfect fine. When they go up from 15% to 20% to 30%, if you don't look at the new power, renewable generation as a system, meaning that you have to pair the solar and wind with energy storage, they will create trouble for the power grid. They may, because if you think about the traditional power generation, like coal-based or natural gas-based or nuclear, it's more like analog device. And renewable power generation, solar or wind, has tremendous volatility and inherent intermittency. It's more like a digital device. And you have very large digital device switch on and off from the grid. That creates a lot of trouble for the grid.
Analog versus digital. That's the
I give you an example. We are building a factory in China, and it's going to be powered completely by off-grid renewables. It's not a small factory. It's a 40 gigawatt-hour factory. When it's done, it's going to generate annual revenue in the order of $3 to $4 billion a year, and it's going to be completely powered by renewables coupled with storage.
Sure.
And it's and it's 15%. The cost is 15% lower than the power cost we receive from the power grid.
Sure.
Considering China's electricity price is already very competitive.
Yeah. Right. So the prices are coming further and further down.
Thank you very much for this session. My name is Hussein Matar. I'm with AMIA Power. We're doing renewable energy projects across Africa. We have today around 6,000 megawatts in the continent at different stages. We know ENGIE and Aqua very well, and we certainly procure a lot of our equipment from China. And I just wanted to understand from your side the impact of this rebate we're hearing that's come into place. How is that going to change the picture in terms of tariffs and prices? Thank you.
Pan, I think that's yours.
Sorry, the rebates, what rebate are you talking about?
VAT rebates. The abolition of the VAT rebates.
VAT rebates.
China.
In China. China is cutting down the VAT rebates, refunding for battery products. I think, is that the question you meant?
How is that going to change the overall prices?
Yeah, I think the rebate, the VAT tax rebate itself, it's not that significant in the long run because we're going to continue to drive technology to drive down the cost. But in the short term, of course, the rebate sort of phasing out from the supply chain will increase the price most likely in the short term.
Thank you.
For the next 6 months.
For the next 6 months, at least.
And thereafter, who knows? Technology would have advanced.
Yeah.
We can take it.
Hello. Very quickly, Venancio Mendez. I come from Texas, work for Wood PLC. So we are developing solar and wind, etc. My question is related to data center energy demand in Texas. We have the development of data centers are causing the increase of 14 data centers are equalizing on demand, similar to the city of Austin. So my question is, how do you envision renewables capturing some of this growth? Because they're also trying to equalize this with combined cycle. And how do they meet that demand? How do you see renewables capturing some of this growth?
Okay, very quickly.
Yeah, I think renewable will play a very important role in meeting the demands of ever-growing, insatiable power demand from AI native data centers in the next 20, 30, 40 years. We have been, for example, Catherine mentioned in the past, it was like 1 hour duration project was the mainstream, right? But we've already last November, we've already installed 8 hour long duration project in Australia. So for AI data center, the challenge for power is very severe on the grid, because other than the amount of the electricity needs, the fluctuation or the volatility of power needs from AI training models and inference models is more than 10 times of the traditional internet data center power needs. Right, so huge amount of electricity and a huge amount of volatility, and then only storage can come in coupled with renewable generation resource, which, as Catherine and also Marco mentioned, it's fast to deploy.
Yeah.
Right, that's one of the very important advantages of renewables to meet the immediate demand of AI data center. But in this process, I think one thing we are a little bit concerned about it is really the long-term safety of a lot of energy storage projects ongoing. Because in the past couple of years, the overemphasis on upfront price from the procurement standards have been leading to a lot of suppliers in this industry to cut corners, resulting in low quality storage products, batteries, presenting long-term safety issues. We are concerned that the hard-earned trust in this industry and investment momentum could be undermined by the future safety incidents. So that's what we've been relentlessly focusing on, making sure the quality is high. We've been pushing the Six Sigma is very, very well known in the industry as the sort of the utmost product quality standards. That means defect parts, ppm, parts per million, right? We've been trying to push it to ppb for defect parts per billion. Right, so bring it up to 3 orders instead of 6 sigma. Now we are doing 9 sigma. We're the only one, CATL is the only one in the industry to do 9 sigma product efficiency. Right, so only with this we think we can make sure the safety, because safety is really for storage products. Is the lifeline and foundational commitment we need to have.
Absolutely. Thank you very much.